So hello students. Now again coming with acid-base theories. Like you know that our the second theory is Bronsted-Lowry theory, and in this Bronsted-Lowry theory, acids are the substances which can easily donate H plus ion, and bases are the substances which are capable to accept H plus ions. Right. Now in this theory, we have some pairs, conjugate acid basis pairs. Now what do you understand by this conjugate acid base pair? Conjugate acid base pair means when there is only a difference of H plus. Remember, when there is only a difference of H plus, such pairs are called conjugate acid and base pairs. For example, suppose we take this NH3. Now for NH3, its conjugate base. Here we write conjugate base and this side we write conjugate acid. So conjugate acid is made up by addition of one H plus. So when we add one H plus in this ammonia, we get NH4 positive. As H plus is added, so 1 plus charge is also present. Right. So this NH4 positive is the conjugate acid of this ammonia, and its conjugate base of ammonia is NH2 minus. Why NH2 minus? Because minus 1 H plus. So when you deduct 1 H plus from this ammonia molecule, then we have this NH2 minus 1. So charges, always remember कि charge कैसे आ रहा है, ठीक है. So conjugate acids are formed by the addition of one H plus, and conjugate bases are formed by the removal of H plus. Right. Another example is HCO3 negative. Now when we add one hydrogen, then addition of one hydrogen means H2CO3, and plus charge neglect this minus charge. So we have this H2CO3. So a conjugate acid of this HCO3 negative is H2CO3, and its conjugate base is, now just remove this H plus. So when we remove H plus, we have CO3 2 negative. So this is the conjugate base of HCO3 negative. Similarly, in case of water, when we add one H plus in this water, its conjugate acid is formed, H3O positive. But when we remove one H plus, then we have OH negative, which is the conjugate base of water. Is it clear now? So always remember कि in case of conjugate acid, we always add one H plus in the given species, and in case to form a conjugate base, we always remove one H plus. Sign का आपको ध्यान रखना है, right? So these are some common examples. Otherwise, there are so many examples, and this conjugate acid base pairs are very important. Some species are given, and your question is कि just write the conjugate acid or base of this compound, right? So this is very important one. Now we take one example. Like our example is we take one example. This is our example, NH3 plus H2O gives NH4 positive plus OH negative. Now in this reaction, this NH3 is a base, right? And water acts as acid. Now why it acts as a base? Because it easily accepts one H plus and converted into NH4 positive. So it is a base. But after the exception, this NH4 positive is the conjugate acid of this NH3. And similarly, this is acid because it releases H plus, it donates H plus. But after the removal of one H plus, now this is the conjugate base of this acid. So we have these two conjugate acid base pair. One is this and another is this. So these two are conjugate acid-base pairs, right? Similarly, if we take another example, like suppose we take one interesting example of HCl plus water. Now this is HCl plus water. It gives what gives? It gives H3O positive and Cl negative. So we have here H3O positive plus Cl negative. Now in this case, which acts as an acid? So here we know that HCl donates its H plus and converted into Cl negative. So this HCl acts as acid and its conjugate base is this Cl negative. So this is the conjugate base. So we have this pair HCl and Cl negative, conjugate acid base pair, and meantime now this water is here. It acts as a base because it accepts one H plus and converted into H3O positive. So this is a base, and after accepting one H plus, then this is called conjugate acid. Why conjugate acid? Now you know that for reversible reaction, now these conjugate base and acids combine together to form these acid and base pairs. So this is our conjugate acid base theories, right? Very important one. We have so many examples based on this also, like write the conjugate acids and bases of H2SO4. Suppose your question is write the conjugate base of H2SO4. Now just remove one H plus from this side. So after the removal we get HSO4 negative. So conjugate base of sulfuric acid is HSO4 negative. And if this species is given HSO4 negative, then its conjugate acid is this, because now we add one H plus here. So this is conjugate acid and its conjugate base is SO4 2 negative, because now from this species we remove one H plus. After the removal of H plus we get SO4 2 negative. So these are conjugate acid base pairs. Very important one. Now coming to our third theory, and this third theory is Lewis acid base theory. Now according to Lewis acid base theory, Lewis acid base theory. Now Lewis acid base means Lewis acids are always electron deficient. So always remember that the species which is electron deficient, acids के केस में क्या हो जाएगा? The compounds, the species which is electron deficient means where lack of electrons takes place, which easily accept one electron pair from other species. These are called Lewis acids, right? And what are Lewis bases? The species which is electron rich. Electron rich means having some lone pairs, and if a lone pair is present or extra lone pair is present, it means these species easily donate their electron pair. So Lewis bases are those electron rich species which can easily donate their electron pair to electron deficient species, right? So simple examples are Lewis bases are all anions. All anions are Lewis bases because you know OH negative easily donated one electron pair, CO3 2 negative, or we can take any other species like SO4 2 negative, NO3 1 negative. So all such anions are electron rich, and these are called Lewis bases. They easily donates. And electron rich species, neutral species, when we take example of neutral species, then our answer is ammonia. On ammonia, nitrogen has one lone pair. So it can easily donate its lone pair. Similarly, in case of water, oxygen has two lone pairs. So it can also easily donate its electron pair. Or we have this HF. HF means fluorine has 3 electron pairs. Right? So these are Lewis bases because they easily donate their electron pairs. Or we have this amine. On amine again we know that nitrogen possesses one lone pair. Now electron deficient species. Electron deficient species like we say AlCl3. Aluminium after sharing its electron got only 6 electrons. Octet is incomplete. So it is electron deficient species. Or we have another one BeCl2, or we have this BCl3 or BF3, right? Then all cations are also electron deficient species because they possess positive charge, means they require more electrons to become neutral. So all cations are also examples. Say for example NH4 positive, Cu2 plus, or any metallic ions we can take here. Right? So these are the acid-base theories. So total in all we have 3 theories. First is Arrhenius theory, right? Then second is Bronsted-Lowry theory, and third is this Lewis acid-base theory. Hope it is clear to you all, right? So just revise once again, conjugate acids and bases. And remember, if a conjugate base is more stable, it means that that acid is a weaker acid. Because always remember, a weaker species is always converted into a stable species. Right? So if a conjugate base is more stable, it means that acid is weak acid. Right? So this is all about your acid-base theories. Thank you.